Hi AP Chem. We just worked on solution stoichiometry. It is Friday, homecoming day. This is going to be the gas law chapter. Pressure. Section 1, pressure. Properties of gases. Well, that's easy. Gases exert pressure. Let's see. Gases are uniformly fill any container. You can take a 3-liter container of gas and release it into a classroom and they will spread out. And in reverse order, you can take a 3-liter container of gas and shove it into a 1/2 liter because gases are compressible. If you mix two gases together, they will mix uniformly or completely with others. The air you breathe is made of 9 different gases, and they are pretty much mixed uniformly throughout, so it's not like you can stand in the back of the room and get more oxygen than the front. They are uniformly mixed throughout. So a mixture of 2 or more gases will mix homogeneously. Gases exert pressure. On its surroundings. And pressure is measured by how hard and how frequently gas molecules hit the side of the containers. So I'm going to shortcut this. Hits. So the more the gas is hitting the wall of the container, the higher the pressure. Gases have extremely low densities, which is a good thing, since again, you are sitting in 9 different gases. And if they had high densities, you would basically be smooshed. So they have extremely low densities, and most importantly, they act what we like to refer to as ideally at low pressure and high temperatures. Now, at low pressure, there's so few gas molecules that there's no attractive or repulsive forces because they're like ships passing in the night on the ocean. They don't even know there are other ones are there. At high temperatures, they're moving so fast that they don't have time to actually react with another gas molecule. So an ideal gas will be at low pressure and high temperature for that reason. Pressure. Pressure is the amount of force exerted over an area. The units of pressure are newtons per meter squared. So that capital N is a newton, which is a very big physics unit, over meter squared, which is equal to 1 Pascal. And of course, Mr. Pascal is the guy who came up with pressure. Now, if you think about it logically, it's basically the amount of pressure felt over a 10-foot squared area. And the Newton, which again you will come across in physics, is basically the force required to accelerate 1 kilogram a meter per second squared. And that's going to be used more in physics. That's just an interesting fact. Right? Pressure units for us, we are still in the American version, and when we go to the air pumps at the local gas station that now charges you for air, which to me is ridiculous, but you need a quarter in order to fill up the tire of your car or bike, is still in pounds per square inch. Whereas the rest of the world went relatively metric or international system of units. 14.7 pounds per square inch is equivalent to 101,325 pascals, which is equal to 760 millimeters of mercury. We use this one a lot, especially in weather forecasting. When they say the barometer is high or low or whatever, that's usually a reading of a column of mercury. Let's see, also you might come across kilopascals. And of course Mr. Torricelli gets his due, so the torr, that's from Mr. Torricelli, who created or had something to do with the barometer. When you convert from one unit to another, just pick and choose what you need. For example, let's say I'm going from I don't know, 5.76 kilopascals, and I want to convert it to millimeters of mercury. You would pick the right parts of this very long conversion factor, and you would just do your conversion. And you did this in first year chemistry. I've had kids in the past start out with kilopascals and go through all of them for no reason. Just pick what you need from this very long conversion factor.